Okay, so from now on, anytime you see a sine or a cosine, if it just has the variable sine theta, cosine theta, assume theta is in radians. In order to do derivatives, we need it to be in radian form. So if I were to ever give you anything in degrees, we would have to convert it. Do you remember how to convert between degrees and radians?
Pi over 180.
We know that pi radians is equal to 180 degrees. So if you had degrees, you would multiply by pi over 180. If you had radians and you wanted degrees, then you'd multiply by 180 over pi. Okay, so just a quick check. Our common degree measurements. 30 degrees is what in radian form? 45? 60? 90? Okay. The other thing I want to mention, the trig functions are continuous at every number in their domain. Continuity is really important because derivatives only exist where your graph is continuous. Now, we said continuous everywhere in the domain, but we know what happened like when we were graphing secant, cosecant, tangent, cotangent. What occurred on those graphs?
Asymptotes.
Yeah, those had asymptotes. So how am I still able to say they're continuous then if they have asymptotes?
Because they go forever. In one period goes forever.
Right. We know the y values continue. And I put that little clause in there, in their domains. Where you have a vertical asymptote, that's a number that's excluded from the domain. So it really wouldn't apply there. So when we work with derivatives of trig functions, we're going to assume that we're talking about somewhere where the graph exists. So some number in its domain, so not an asymptote. A couple things you want to remember. At the very beginning, I gave you a trig handout, and I had some important formulas on there. Two of the ones that are going to come up right now would be our most important ones. Sine squared theta plus cosine squared theta equals 1. The second one, this is not one I ever made you memorize. It was in our little book of formulas at the end. If you have the sine of two angles add together, you can split it up. Sine x cosine h plus cosine x sine h. So those are going to be a couple formulas that will pop up throughout this section. Today, most of our emphasis is going to be figuring out what these derivatives of trig functions are. And then eventually those will just be things that you need to know moving forward. So today we're going to focus on how to get them. Back in section 2.2 when we were talking about limits, this was one of the results we had. The limit as theta approaches 0 of sine theta over theta is equal to 1. So keep that in mind as we move forward today. So let's say I actually do this limit, because derivatives are really limits, right? This is one that we're going to need. If I ask you to do this limit, can you just plug 0 in? Why? Makes the bottom 0. So what are we going to do instead? What are some strategies? That's if you're doing the derivative. We would do quotient rule. Let's try multiplying by a conjugate. So you'll notice we've gone back to a limit for a minute, not a derivative. So if you FOIL at the top, you get cosine squared minus 1 over, I'm going to leave this as theta times cosine theta plus 1.
It equals sine squared theta.
Okay, almost. Cosine squared minus 1 is almost sine squared theta. It would be negative sine squared. Do you guys agree with that? Let's plug that in. going to separate this. Negative sign squared. We could separate that into a sign times a negative sign. Would you guys agree with that? The bottom, I'm going to just pull that apart. I'm going to put theta under one of these and cosine theta plus 1 under the second. Now, if I were to multiply these two fractions together, I'd still get the previous fraction. So I haven't changed my problem. I've just pulled these fractions apart. Because with limits, we know if you have two things multiplied together, you could do their individual limits, right? So really, here, I have the limit as theta approaches 0 of sine theta over theta times the limit as theta approaches 0 of negative sine theta over cosine theta plus 1.
Question. How were you able to find the denominator of this stuff?
They're just multiplied, not added. So if you were to multiply fractions, you just multiply the tops, multiply the bottoms. It gives you back the same thing. If they were adding, we would not have been able to split up the denominator. We know what this is. What does that piece equal? Okay. Can I evaluate this piece now? Negatives, what is the sine of 0? 0. What's cosine of 0?
One.
1. So what happened is I work this out and I get 1 times 0 over 1 plus 1 equals 0. Okay, so this is going to be another useful piece that's going to come up in future sections. Now we know that the limit as theta approaches 0 of cosine theta minus 1 over theta is equal to 0. Alright, we have a couple of these limits. Without looking ahead, we're going to try to figure out some derivatives here. So let's talk about sine. If you need to, pull out that graphing handout we did at the beginning of the year. Remember, sine looks like this. So here's our graph of sine. Now, I want to figure out the derivative from this. So keep in mind, anywhere your function has a maximum or minimum, what's the derivative? 0. So my derivative would be 0 here and here. This function was, or this part was increasing, so that tells me my derivative was positive. And then it was decreasing, so the derivative is negative. So it's going to be positive, then it's going to be negative. Still decreasing, so still negative, but we have to come back and hit our 0. Then this part is increasing, so the derivative is positive. What does that remind you of? The derivative of sine is cosine. Let's work it out and prove that that's the case using the definition. So the definition of derivative is the limit as h approaches 0. F of x plus h, here my function is just sine x, of x plus h is sine of x plus h minus f of x all over h. But I told you at the beginning that trig formula we are going to be using, sine of x plus h. You can use that formula from our trig identities and split it up. That's sine of the first, cosine of the second, plus cosine of the first, sine of the second.
I'm confused.
Okay?
Why are we doing the limit but
This is the definition of derivative. Before we knew the shortcut, every time we did the derivative, we did the limit as h approaches 0 of f of x plus h minus f of x all over h. This was our long way of calculating the derivative before we had all of our other rules. So since we don't have a rule for trig functions yet, I'm working it out the long way. Okay. This is kind of messy, isn't it? The problem is, I can't plug in 0 yet because this h is on the denominator. Right? Let's say, I kind of separated some things. If you have pieces added, you could regroup them and do their limits individually. So I'm going to pick the first and the last. So I'm going to put those together because they both have a sine x in them. And then you would have to add in the limit of the middle term. So right now I'm really just doing some fancy algebra. Probably would not expect you guys to come up with this on your own right now. I'm just wanting to see, can you follow what I have done? So we have this fraction. You could split it up and put each term over the denominator. Both of these had a sine x, so I said, okay, let's keep those two together. And let's take this one out by itself.
so you can split up the numerator but you can't split up the
Right. So now, what could I pull out of this? A sine x. This one, I'm going to just separate out this cosine next for a minute.
Is that sine x over 1?
Yeah, it's just like over 1.
Okay.
Okay. This is the limit as h approaches 0. So sine x wouldn't change. It doesn't have an h in it. Look at the last box that we did. What's the limit as h approaches 0 of cosine h minus 1 over h? It's 0. That's what we proved at the beginning. Okay? Limit as h approaches 0 of cosine, it doesn't have an h in it, so it would stay. What's sine h over h turn into? 1. That was the very first piece that we had today. So we get this entire derivative to be cosine, like we suspected from the graph. So that was really a proof. I just proved to you that the derivative of sine is in fact cosine.
Were you doing the okay, so you did the limit and then the derivative was sine x there.
No, this whole thing was the definition of derivative. So that proved that the derivative of sine is cosine. So you're wanting to use a shortcut derivative rule, and I haven't given you one for trig yet. So we were going back to the previous definition when you had to work it all out. And the answer is the derivative there, the answer to that So that was the proof. You never have to recreate that. Now you can accept it. I proved it to you. You believe me. So from now on, you don't have to do the definition. The derivative of sine is cosine.
Not all problems are gonna be on the derivative of sine, it's gonna be different on it.
Okay, so using that, let's see if we could do this one. So if I ask you to do this derivative, what rule am I going to have to use? Product rule. So our derivative, product rule, is derivative of the first. So derivative of x squared is 2x times the second, which is my sine x, plus the first, so x squared, derivative of the second. But now we know the derivative of sine x is cosine x. So that's really it. You could write it without parentheses if you wanted, but there's no other simplifying we can do here. Unlike polynomials, who, as you went on, their derivatives got nicer, typically with trig functions, the more you do it, the uglier it's going to get. Is this one okay? Let's find the derivative of cosine. So once again, we don't have a rule yet, so I have to use the old definition. So our function is cosine. The derivative is the limit as h approaches 0 of f of x plus h minus f of x all over h. We're going to need another trig rule here that I forgot to write down at the beginning. Another formula from trig that we're going to be using on this one. Cosine of x plus h is cosine x cosine h minus sine x sine h. Just as a little side note, add those to the other two we wrote down earlier. Okay. I'm going to use this definition to try to figure out the derivative of cosine. So we have the limit as h approaches 0. F of x plus h would be cosine of x plus h minus f of x, which would be cosine x, all over h. So use that formula I just gave you. Cosine of x plus h would be cosine x cosine h minus sine x sine h.
Group cosines together.
So we're going to split it up just like we did on the previous one. We're going to try to keep like things together, so both of these terms have a cosine x in them. So I'm going to put those two together. And then we would have minus, because of that negative, the other one. And I lost somebody.
Take out cosine, cosine x.
I've been meaning to return this to you for like,
Oh.
you know, 3
I totally
weeks, 4
forgot.
weeks, 2 months, I don't know.
Thanks.
Okay, so that would be sine h over h. So now, cosine x, that doesn't have an h in it, so it's just going to stay. What's cosine h minus 1 over h? The limit is equal to 0. That's 0. The sine x would stay. What's the limit as h approaches 0 of sine h over h? So we get negative sine x. So there's your proof, because you guys wouldn't have believed me if I just told you the derivative. Now you know why it is. So the derivative of cosine is negative sine. And from now on, you just need to know that. Okay, so we have to know these trig derivatives. Derivative of sine is cosine, derivative of cosine is negative sine. I'm going to go ahead and give you tangent today, and then we'll save the other functions for later. The derivative of tangent is secant squared. Now this one, if you know sine and cosine, if you forgot any of the others on the test, you could actually figure them out pretty easily. Because tangent is what?
Sine over cosine.
Mm-hmm. So if you forgot the derivative of tangent, you could change it to sine and cosine and do your quotient rule. So low d high, what's the derivative of sine? Minus high, so my sine x. D low, what's the derivative of cosine? Over the bottom squared. You guys following there? Cosine times cosine, negative sine times negative sine, it's a positive sine squared over cosine squared. Cosine squared plus sine squared is 1. So you get 1 over cosine squared, which is secant squared. So the nice thing is, if you remember sine and cosine, you could do all of the other 4 functions just by quotient rule, if you needed to. Alright, questions there? Let's do one more and then we'll stop for today. Let's just work this again. How would I do this derivative? Quotient rule. So low d high, what's the derivative of cosine? Minus high. D low, what's the derivative of 1 minus sine x? Because the derivative of 1 would be 0 minus cosine. All over low squared. We start cleaning this up. We could distribute the negative sign. So 1 times negative sign would be negative sign. Negative sign times negative sign is positive sine squared. Minus cosine times negative cosine would make that positive cosine squared. Now what? sin x plus 1? Isn't that same as 1 minus sine?
One of them cancel.
Yeah, you can cancel them, so you get 1 over 1 minus sin x. And that's our final answer. Questions? That's our stopping point for today. If